Hey guys, welcome back to another maths video with me, Excellent the Maths Doctor. Okay guys, so today we're just gonna be focusing on another very interesting topic, which is proving trig identities from grade 11. Okay, so if you can look from the screen there, we have an equation whereby we have tan theta minus cos theta over sine theta equals 1 minus 2 cos squared theta over sine theta times cos theta. Okay guys, for us to be actually able to prove the identities, we just have to know what certain identities are equal to. For example, what I mean is, let's say you have tan theta, right? Another way to express tan theta or an identity of tan theta is sine theta over cos theta. So in other words, instead of writing tan theta, you can just write sine theta over cos theta instead. Another one, for example, let's say you have theta, sine squared theta, right, plus cos squared theta. The identity of sine squared theta plus cos squared theta is 1. So in other words, instead of writing sine squared theta plus cos squared theta, you can just write 1 because that's what it's equal to. And you can make one of the ratios to become the subject of the formula. For example, let's say if we put sine squared theta on one side of the equal sign alone, right? We can actually transfer cos squared theta to the side of 1, whereby it will become a negative because it's keeping the equal sign, so the sign must change. So it's going to be negative cos squared theta. So this sine squared theta equals to 1 minus cos squared theta is the same identity as this one. It's just that for sine squared theta equals to 1 minus cos squared theta, I just made sine to become the subject of the formula, but it's the same thing. The only difference is that I took cos to the other side. You understand? So there are a lot, guys, that you can look at. I was just showing you, some of them that can be very helpful for what we are going to be discussing right now. Okay, let's remove this. Okay, right. So from our equation here, this is what you're gonna do. If you're required to prove an identity, you're just gonna take one side and one side of the equal sign and prove that it's equal to the other side. What I mean is, okay, for example, let's say we take the left hand side of the equation, right? The left hand side of the equation is this one. It's equal to what is whereby we have tan theta minus cos theta over sine theta. This is the left hand side of the what of the equation. So we can just take the left hand side of the equation and work with it until it looks identical to this one. That's how we prove trig identities. We just have to prove that the left hand side and the right hand side are equal. How? By taking the left hand side and working it out until it looks the same as the right hand side. You get the point? So let's get into it. So the first step will go like this. Remember, when I was showing you some of the identities that you can use, I mentioned that tan can be written as sine theta over cos theta. So this is just an identity of tan that can be used for the or that you can make use of. Okay, then we say minus what? Minus cos theta over sine theta. Okay, so this is the first step. The first step is to take tan theta and express it as sine over cos. Okay, then once you're done doing that, if you can look very carefully, guys, we are dealing with fractions here, and the fractions are being subtracted. Okay, so if you are dealing with addition or subtraction of fractions, there's gonna be a necessity for you to look for what we call an LCD. Ne? The LCD is always necessary if you are dealing with addition and subtraction of fractions. So here we have two fractions that are being subtracted, so we're gonna need an LCD. What is the LCD? The LCD is just it's just supposed to contain what your denominator consists of. You understand? For example, our denominator here, in the first fraction, the denominator contains cos theta. In the second fraction, the denominator contains sine theta. So if we were to write an LCD, guys, what we would just simply do is just to write sine theta times cos theta. Why? Because both of them are in the denominator. I don't know if that makes sense to you all. So sine theta and cos theta both come from what? From the denominators of the two fractions that we have. So it means that they're gonna be what? They're gonna both be part of our LCD. Simple as that. Okay. Then for the next step, this is what you're gonna do. You're gonna say equal to sine theta over cos theta, right? Then you look at the denominator of the fraction. The denominator of the fraction is cos, but our LCD, it has cos and sine, you see. So what you are trying to do now is just to make sure that all the denominators of the fractions that you have are identical to what? To the LCD. So all the denominators of both of the fractions must become like the LCD. Okay, so the first fraction, we have cos theta. We need to have sine theta as well, like the LCD. So what are we gonna do? We're just simply gonna multiply the first fraction by sine theta over sine theta. Why? So that the denominator can contain cos and sine at the same time, because that's what the LCD has. Okay, so we're just trying to make the denominators to become like the LCD. So we're gonna go to the second fraction and we do the same thing. So for the second fraction, I'm just gonna have to extend it to, let me do it like this. The second fraction is this one, right? Cos theta over sine theta. So let me write it down here. I'm gonna write minus cos theta over sine theta, right? So the second fraction, it only contains sine, sorry. It only contains sine, right? And the denominator has both sine and cos. So the second fraction, it lacks the cos from the LCD. So we are supposed to do what? To make sure that the cos is what is introduced into the denominator of the second fraction as well. So how are we going to do it? So it means that the second fraction, we can just times it by cos theta over cos theta, just so that the denominator can have both sine and cos. Remember, the first fraction, it had cos only as the denominator, so that's why we had to times by sine to make sure that the denominator has both the cos and the sine. So that's our aim here, right? Okay, so let's work it out. It's gonna be equal to sine times sine. First of all, it's gonna give us sine squared, right? Sine theta times sine theta is gonna be sine squared theta over, let me do this quickly, over, then the denominator is cos theta times sine theta. Cos theta times sine theta is just gonna be sine theta cos theta, right? Just write them close to one another like this. Then we say minus, we go to the next fraction, we multiply cos theta times cos theta, which is going to give us cos squared theta, right? Then we say over what? Over sine theta times cos theta. So I just write sine theta cos theta. See how we do it? So now the denominators are the same, because we were aiming to make sure that all the denominators, they look like the LCD. So now our denominators all contain sine theta and cos theta. Okay, so let's do it like this. I can just put the numerators over the same denominator, because the denominator is the same, isn't it? So I can write equal to, then I write sine squared theta minus cos squared theta. Then I write over what? I write them over the same denominator, because they share a common denominator, which is sine theta cos theta. Okay, so I put cos squared theta and minus sine squared theta over the same denominator. So it's going to be over sine theta times cos theta. Okay, guys, then we go to the next step from here. This is how it's going to go. We're going to have equal to, okay, guys, for, if you can look at the denominator, let me show you something. The denominator, which is sine theta cos theta, right? I'm just gonna go back a bit. It already looks like the right hand side, because the right hand side, the denominator is sine theta cos theta as well. What we are left with is what? Is the numerator. We need to make the numerator the same as the one on the right hand side, okay? Because now our numerator is what? Is sine squared theta minus cos squared theta. So we need to make it look like the one on the right hand side. How are we gonna do that? Okay, we can see that on the right hand side, guys, we have cos. You see it? the numerator has cos. It does not have sine. Okay? According to the way they've written it, it only contains the cos. So we should try to express it in the form where we're going to have cos only. Okay, so this is what you're gonna do. You're gonna try to express sine in the form of cos. How are you gonna do that, guys? Remember when I told you that there is a trig identity whereby sine squared theta plus cos squared theta is equal to 1, right? Then I even explained that you can try to make one of them the ratios to become the subject of the formula. For example, you can leave sine, okay, let me just do it with cos. You can leave cos squared theta, for example, right, on one side like this. So it's cos squared theta on one side, then you take sine to the other side. You just choose. Even if you want to leave sine squared theta on one side alone, you can also do that and take cos to the other side. But this time I want to make cos the subject, okay? Because remember I said the denominator must contain cos like the right hand side. So I'm going to make sure that cos is the subject of the formula. Then oh no, okay, let me make sine the subject of the formula because we have sine in the equation here. You see it? Our equation is sine squared theta. So we're trying to change sine squared theta to cos. So I'll just make sine the subject. Ne? So I'll leave sine on one side like this, sine squared theta. So what I'm going to do, I'm going to transfer cos to the other side. Ne? So it means that I'm going to be left with sine squared theta on the left. Then on the right, we have 1, right? Then when cos comes to this side, it becomes a negative cos. So it's going to be negative cos squared theta like this. Okay. So in other words, instead of writing sine squared theta, you can write 1 minus cos squared theta. So yeah, I think the best way is to make sine the subject so that you can know, okay, in the place of sine, if I want to put cos, I can write it like this. Okay. So in the place of sine squared theta, you can actually write 1 minus cos squared theta, because we see that according to the identity, if we put sine on one side and we take cos to the other side, what will we have? We will have sine squared theta equals to 1 minus cos squared theta. So that's what we're going to do, guys. In the place of sine, let's put 1 minus cos squared theta. So I'm just going to scroll up. Okay, let's do this. So this is our sine. So in the place of sine, I'm going to write 1 minus cos squared theta. We saw that sine squared theta can be equal to this, right? Then I write minus cos squared theta. So all this is just you working with identities, okay? If you know that sine plus cos should be equal to 1, you can also be able to make one ratio to become the subject, just like we did with sine when we put it on one side and take cos to the other side. So sine is equal to 1 minus cos squared theta. Sine squared theta is equal to 1 minus cos squared theta. So in the place of sine squared theta here, that's what I put. I wrote 1 minus cos squared theta in the place of sine squared theta. Then we have minus cos squared theta over what? Over sine theta times cos theta. Okay. We are making progress. We are almost done, guys. Almost done. Then from here, this is what you're going to do. You write equal to, right? Then these are like terms, guys. Ne? We have cos squared theta. We have 2 cos squared theta in the numerator. Okay, here there is a negative sign in front of cos squared theta. What is the coefficient? You must know that if they don't write a number in front of the cos, the number is going to be 1. Even in front of this other cos squared theta, it's 1. Okay, so we have -1, -1. I'm just writing those numbers so that when we add or subtract where it's necessary, you guys can know where it came from. Okay, so there's an invisible 1 in front of each cos. Is the same as variables. If they just write x, it means that there's an invisible 1 in front of what? In front of the x. It's always like that. So if there's no number in front of cos like this, it means that the number is what? It's an invisible 1. Okay, so this is what you're gonna do. Here it's -1. Okay, and here it's -1. So you just say -1 minus 1, because they are like terms. You can actually add or subtract their coefficients. Okay, so I'm gonna write 1. the one in front, this one, right? And I say negative 1 minus 1 from the 2 cos squared thetas. So negative 1 minus 1, if you put it on your calculator, it will give you a negative 2. So negative 1 minus 1 is negative 2. So I'm adding them, or I'm subtracting them, right? So negative 1 minus 1 gives us negative 2. So it means that it's going to be negative 2 cos squared theta, because each of those negative ones comes from cos. Okay, so we are adding the coefficients of what? Of cos squared theta. So when we add them together, we get a negative 2. It means that it's going to be negative 2 cos squared theta. Then we put it over what? Over sine theta times cos theta. Then basically, guys, we are done, because this is actually equal to the right hand side. Let me show you. This is, look at it, it's 1 minus 2 cos squared theta, right? Over sine theta times cos theta. Let's go and look at the right hand side and see. Same thing. 1 minus 2 cos squared theta over sine theta over cos theta. So we actually managed to take this and make it into this. So proving identities just as simple as this, guys. Make sure that you use what? Identities. That's all you require, to know certain identities so that you can make use of them in your calculation, or as you are busy converting it to become like the right hand side. Then yeah, basically we are done, guys. Very simple. Okay, guys, if you really found this video to be helpful, and you really think that it helped you a lot in terms of getting a better understanding in terms of trig identities, you can just subscribe to my channel so that you are notified next time I drop another maths video. Okay, so subscribe to the channel and like as well, and you can also share the video. And yeah, basically I think for today this is all, guys. Okay, before you all leave, there's another very important thing. If you are interested in joining my maths classes, guys, all you need to do is just contact the number on the screen, 081 703 1197. And another thing, I teach from grade 6 to grade 12. So if you want to enroll for any of those grades, you just contact the same number, and then you'll get availability of two packages. Ne? The first package is whereby you attend once a week, meaning that you're going to be attending 4 times a month, and that package is 300 rands per month. And then the second package is the school version, where you attend from Monday to Thursday. It's almost like going to school. So you attend from Monday to Thursday, meaning it's 4 times a week. So that one in a month is going to go to 16 times a month. So you're going to be attending 16 times a month, and that the second package is just 650 rands per month. So you just contact the number and select whichever package that you see that is most fit for you. Then yeah, you'll just enroll for that particular package. Then basically that's all for today's class, guys. I thank you so much for your time. Hope that you're enjoying the videos, and make sure that you like and subscribe so that you can be notified next time I drop another maths video. Okay, thank you so much. Bye, guys.